Hello, and welcome to RRI Explained, a ResBIOS podcast. It is the aim of the ResBIOS project to embed responsible research and innovation, or RRI, into 4 universities across Europe, in the hope of improving the interconnectivity between science research and society, with a particular focus on the biosciences. But what is RRI exactly? Well, hopefully we can find out together. On today's episode of RRI Explained, we are joined by Professor Bernd Stahl from the University of Montfort, who's going to talk to us today about RRI and emerging technologies. Thank you for joining us today, Bernd.
You're welcome. Thanks for having me.
Would you mind just giving a quick introduction of how you started to work within the field of RRI and how that interconnects with ITC and emerging technologies there within?
I originally started out my academic life as an industrial engineer. So I studied mechanical engineering and a bit of business. And doing this in Germany in the 1990s, I thought I would probably end up building cars at some point. It just so turned out that then I got interested in normative questions. I studied philosophy as well. And I ended up doing my PhD work around the intersection between technology, business, and society more broadly. And I looked particularly at questions of responsibility in information systems. So that was in around the millennium. And I then ended up here in the Montfort University. I came over here in 2003 when this was the probably only reasonably large research group specifically looking at the ethical aspects of IT. So that topic has grown immensely since, but about 20 years ago, that was still very much a niche area. So my research interests in this area go back a long time. And then the concept of responsible innovation emerged somewhere along the line. So for me, the official starting point for engaging with the concept of responsible innovation or responsible research and innovation was in around 2010, 2011, when we, in this case is Professor Marina Girotka of the University of Oxford and myself, put in a proposal to the UK Engineering and Physical Research Council around what was initially called a framework for ethics in ICT. That was at a time when the concept of responsible innovation started to become prominent, in particular also with the funder. So the EPSRC, the Engineering Physical Science Research Council, adopted this concept as part of their strategy. And we then changed the name of the project from Framework for Ethics in ICT for Framework for Responsible Research and Innovation in ICT. And I think that project started around 2011, 2012, somewhere there. And I have sort of been in this discourse around responsible research and innovation, both in the UK and on the European level ever since.
That's really interesting. So just for our listeners who may have heard the terms of emergent technology and AI, is there a quick way of kind of describing what these technologies are and how they are informing kind of the research that you're doing?
No. So it's certainly not easy to easily define emerging technologies. But I guess for the purposes of this sort of conversation, one could say that emerging technologies are typically seen as technologies that have the potential to significantly change the way we do important parts of our life. So that would be my short introduction. So emerging technologies don't necessarily have to be new. In fact, most of them aren't. AI is absolutely nothing new, but they are perceived to be emerging when they are at a stage where there are reasonable expectations that they will actually have a significant impact. So that's how I would define emerging technologies for the purposes of responsible innovation.
So how have you been using these emerging technologies within your work, within RRI, and the work that you do with projects such as the Human Brain Project?
So in my work, the concept of emerging technologies became important in the first EU projects that I coordinated. That was something called Etica, that looked at the ethical issues of emerging ICT applications. So that's what Etica stands for. This project that ran from 2009 into 2011 really aimed to give a broad overview of what we perceive to be emerging technologies at the time, and to look at what ethical issues these were expected to raise and how they might be addressed. So it was these days I might call it a horizon scanning activity. So an attempt to get a general overview of what are those things, where are they hidden, what do they look like, and what do we at this point expect they will do, with the consequence of thinking about what could we do in order to address possible issues, but also in order to promote positive consequences. So that, as I said, 2009, 2011, and I sort of have been working in this space ever since. So this idea that there are technologies that don't already exist or don't already do everything they can do, but rather that they have the potential to broaden their scope, have more impact, has always been around, certainly in my area of work. And I think that's also a driving factor behind this idea of responsible innovation. Because responsible innovation is, to a significant extent, about thinking what might be future consequences. How can we get a handle on them? How can we understand them? How do we know what different perspectives of them are? So responsible innovation, I think, is very closely linked to this concept of emerging technologies as something that will have the next big impact that we should think about now.
No, that's really interesting that you put it that way, because I just had in my notes that because of your philosophical background, a lot of the work that you must do must revolve either kind of future-proofing or being kind of a futurist about how these technologies could impact on society and in ethics going forward, I suppose. But there's also that sort of drive between maintaining kind of innovation and kind of pushing the envelope a little bit. I'm just wondering what your thoughts are about future-proofing these sort of technologies and making sure that, is it possible to do such a thing, or do we just have to sort of roll the dice and hope?
So yes, I agree that a lot of the work I have been doing and I continue to do could fall into this broader category of future studies or foresight studies, of thinking about possible consequences, thinking about the scenarios of what the future might hold. And you of course, put your finger on one of the main weaknesses there, namely, we don't know the future. And the future, by definition, is unknown. And therefore, a lot of people are justifiably skeptical about this endeavor of trying to preempt possible consequences and deal with them. Now, I think you could have two extremes in this debate. You could say, on the one hand, there are the people who say, yes, we can actually predict what's going to happen. So there are technologies that have clearly defined consequences, and we know how they are going to play out. And on the other side, the other extreme would be, no, we don't know anything about the future. And I think both of these extremes are probably not entirely convincing. And social reality will probably meet somewhere in the middle, because we do know a lot of things about the future. And we live our daily lives on the assumption that the future is predictable to a certain extent. And our societies are built on that, and they work. Things like, we know how many people are going to get married next year in the UK, for example. Now, we have a fairly good idea, and we have confidence intervals where we can say it's going to be between this and that. And we can be fairly certain that that's going to happen. We don't know whether you're going to get married or I'm going to get married, but we know that on a social level, there are certain things that are very likely to happen. And I think similar types of reasoning can also be applied to technology. So we don't know exactly what the next AI application will be. We don't know exactly how it's going to hit, but we do know that there will be new applications, that we have a clear understanding of the capacities of technology at the moment. We know that people are working on in terms of future capacities, and therefore we can make reasonable guesses about what's going to happen. Now, I think the certainty of such guesses decreases over time. I think we could be, I'm fairly confident that nothing very surprising in the world of AI is going to happen next week. I'm less certain that nothing's going to happen in the next year. And I'm absolutely not certain that nothing's going to happen over the next 50 years. And I think that the value of thinking about the future is not to be able to predict it, because we can't, but the value is to sort of accompanying development process of technology with a view to making well-educated guesses that help us design the future that we want to achieve. And I think that is possible to a certain extent. We need to avoid the fallacy of predicting the future, because we can't, but also we need to avoid passivity because we think we can't do anything about it. So we need to find a good balance somewhere in the middle.
As technology develops, of course, over the past 10 years, we've had the kind of birth of ubiquitous internet, smart technologies. Along with those lines, there's been kind of a big growth in the idea of citizen science and having kind of like this ease of data collection. I'm just wondering what you see the advantages of using these emerging technologies are for future research projects. What, of course, AI has the capacity to do lots of calculations that would be impossible for a single person to do in a lifetime, and learn and actively learn from that sort of thing. But I'm just wondering, as these emerging technologies continue to improve, how do you see them being utilized in bioscience research moving forward?
So I think the main advantage of AI in current research, and AI, this is machine learning type of stuff, big data analytics, is that, as you said, these technologies can analyze data sets which are way too large for manual investigation and analysis. To give you an example, I'm currently part of a project that brings together a number of different types of data sources in the area of neuroscience, and it aims to find out what are the environmental factors that impact mental health. So they on the one hand, they have cohort studies, neuroscientific cohort studies, which have been collected over a long time, over many years. On top of that, they now want to make use of citizen science, so they will develop an app. This app will allow people to record their environment, their mental states. They will also link that with environmental data, weather, temperature, urbanicity, that sort of stuff. And then try to build an extremely complex model that would identify what causalities exist, what relationships or correlation exist between those different factors. Whether that's going to work or not is a scientific question, which I can't answer at this point, but I think it points in the direction of what a lot of science now does. So they bring together huge amounts of data. We now have more data than we ever had before, and we can also combine it in ways that we didn't do before. So this idea that a neuroscientist would look at weather reports probably wouldn't have made sense in the past, but it does make sense now. If you think about the recent heat wave, this has potential mental health consequences, and understanding what the relationships are would be helpful also in order to do something about them, potentially at least. So I think that really is where current AI technologies offer opportunities for research, for understanding the world that simply didn't exist prior to these types of technologies. I mean, I think in practice, what it boils down to is statistical analysis of big data sets. So that's what AI can do in ways that we couldn't do before. And I think that's where I see the most tangible and likely benefit for science and research.
So I suppose it's just sort of analyzing this data and then kind of this pattern recognition sort of capacity of this technology. Kind of the other side of the coin, I suppose, when we're looking at RRI, obviously there's a big focus on ethics, but also a big part of that is open science and public understanding of these technologies. But as these technologies get more and more advanced, I'm maybe talking more about kind of the development of AI and machine learning, where not really any, like there's a degree of uncertainty about how these machines or these algorithms kind of, how they evolve themselves. So I'm just wondering, like, how do you rationalize that with the RRI kind of aspects of just sort of, there's going to be some things we don't know, and perhaps, making sure that there's no ingrained biases. Like, how do you kind of ensure that these issues are kind of faced kind of at the beginning of integrating these technologies?
Yeah, that's a question that I think the research community is struggling with. It is, I think there's probably no guarantee that nothing's going to go wrong. Mm-hmm. I think there are some very high profile topics in the area of AI that everybody's aware of. You mentioned the biases, discrimination. There are also questions around privacy, data protection. I think these questions are not resolved. I mean, they are still subject to debate, but I think what fills me with optimism is that they are very high profile, that there's a lot of work being done on them, that there are many attempts to ensure that no negative consequences arise from them. Well, the fact that we don't necessarily understand what exactly happens in an artificial neural network, to my mind, isn't really the worst thing in the world. Do we really need to understand everything? Well, do we really understand how the brain works? Probably not. Therefore, the assumption that you have to understand every little component of something, let's call it a system, in order to assess whether the working of the system is societally acceptable is probably wrong. So what we need to do collectively as a research community is to identify the parameters. So what level of confidence do we need to have in order to let loose an AI algorithm on a particular data set? I think the most high profile examples of that would be from the health domain. At what point would we rely on a diagnosis from an AI system to the point where we would start an intervention because of it? I think these are interesting questions, and there are no straightforward solutions or answers to them. But I think that there's a lot of work being done on them. So to my mind, this is, from the responsible innovation perspective, it's a question of the processes that need to be in place in order to ensure that the technologies do what they're supposed to do. And again, there's a lot of stuff happening in this field at the moment. For example, at the current EU guidance for AI projects, there are various processes that are being proposed. There is, for example, algorithmic impact assessment, such as the one that was proposed by the European High-Level Expert Group on AI. There are proposals around how you do ethics by design for AI. There are methodologies that allow researchers to do that. So there are various aspects and approaches in that direction. Now, at this point, they don't really marry up. They don't come together yet. It's not a consistent and coherent approach, but there are lots of ways in which researchers can address these questions. And I think we're still in the exploratory phase where we're trying to figure out what works and what doesn't work.
So no, that's really interesting, because kind of my follow-up question for that would have been, what digital safeguards kind of policy and ethical governance does this need to be done at a company level, at a governmental level, or like an institutional level? But from the sounds of it, it's still kind of untrod territory a little bit. We're still kind of finding our way a little bit.
Well, it is, but it's not like we're at the start of the journey. So there are a number of proposals out there. The question of what level does the responsibility sit at? So who is it that should be responsible? Is it the state? Is it the organization? Is it the individual researcher? Well, the answer to that is probably all of them to some degree, and these responses have to correspond. So legislative framework may require certain things which will have to be implemented by organizations which will rely on the expertise of individual experts and so on. So I think these things are not exclusive, and I think the European approach, where the AI Act is being explored, is an example of that, where the European Union has thought about what is it that we would need to have in place in order to have confidence that these technologies do what they're supposed to do and that they don't harm people. And then they've proposed certain mechanisms whereby this could be checked. And I mean, the AI Act, it hasn't been passed yet. So, and if it were, it hasn't been tested. But this is, I think, an example of how current thinking is evolving. So there are different levels, different types of organizations that have to work together. And yes, we are still at the testing stage. We will find out whether this works. We will see whether it actually does make sure that, that there is no misuse there, or there's no foreseeable misuse, and that these sort of approaches do the job.
As well, I think it's probably become fairly apparent that ITC and these sort of emerging technologies are very much in the Venn diagram of all of our research, I suppose. Kind of modern research has some aspects of ITC, or information sciences, just ingrained into just how we process information and data nowadays. I'm just wondering, what are your thoughts about the future of this technology and how it might kind of incorporate the future of research and the future implications on RRI, perhaps?
Yeah, that comes back to the question we discussed at the beginning, namely the possibility of foreseeing the future. What I suspect is probably relatively uncontentious is that the capabilities of these technologies to do what they're doing, which is really around pattern recognition, statistical analysis of large data sets, that they would probably get better at that. So they may, or I think that they're very likely to be able to develop models using less data than they do at the moment. I mean, one of the downsides of current AI machine learning techniques is that they require huge amounts of data to learn something, whereas humans don't. So I think that we will see a lot of efforts in the direction of making them more human-like, in the sense that they can learn better from smaller data sets. They may strengthen their ability to detect patterns, maybe distinguish between real patterns and imaginary patterns. I don't know whether that's possible, but that's something I could imagine might happen. So those are I think the immediate consequences. Now, what are they going to do in 5 years' time, in 10 years' time? I find that very difficult to predict, and I certainly wouldn't want to be quoted in 10 years' time about something I say now, which just turns out to be complete nonsense. So, which is, I think, one of the reasons why we need to understand response innovation as a process that goes alongside the technology development. And I personally don't think that there's current AI techniques are likely to lead to anything earth-shatteringly different. And if you look at the history, most of what we now see as the success of AI has been around for many years. Artificial neural networks have been around for decades. The success of those neural networks and of deep learning in the last 15 years really didn't come around from developments in the technology, but from development in terms of the availability of data and the availability of compute power. And therefore, I think it's an example of a development which the people who did AI at the time, so the people who came up with this idea of artificial neural networks, probably wouldn't have foreseen, because all of a sudden these things become successful long after they've been established because of technical capabilities which weren't there at the time when they were developed. And I think something similar can happen again. So there may be other types of, I don't know, maybe quantum computing does something which is completely unthinkable at the moment. But I cannot predict that.
So a lot of the work that you currently do, it's quite collaborative with other fields of science, such as the work that you do with the Human Brain Project. And it feels like, the world of ITC is going to continue just to overlap within these other fields, I suppose. And it's going to be a very exciting field to be in, and just sort of like the availability to kind of, work within your own field, but also branch out to other kind of fields of study that sort of interest you as well, I suppose. Would you say that was true?
Yes, that is true. So firstly, I agree that there are probably very few research fields where you can get along at this point without significant computing experience, power, and so on. Certainly in any of the field of natural sciences, there's a very strong drive in the direction of more data and more data analytics. I think COVID was an example where a lot of the people who did research on COVID actually never studied the virus itself, but only looked at the genetic makeup. Right? So you can now do stuff with computers, purely with computers, without looking at anything else that previously would have required bench science and so on. And I think that is a process which I suspect will probably continue. And that's true for the biomedical world, but it's probably also true for physics and astronomy and you name it. I think all the natural sciences, and to a significant extent also in the social sciences and humanities, where more and more data is collected for a variety of purposes that requires computing resources to be analyzed.
So last question, really. In your book, Artificial Intelligence for a Better Future, you talk about the concept of human flourishing, which I quite like the idea of. I'm just wondering if you could describe what this concept means to you, I suppose.
Yes, so this comes out of the Sherpa project. And what we try to do there is get a handle on which ethical issues arise from this combination of big data and AI, and how we can approach that from an ethical perspective with a view to somehow finding resolutions or ways forward. And one of the problems that you run into when you think about this sort of ethical question is the concept of ethics. So what do we mean by ethics? And of course, ethics as a branch of philosophy has a huge history and numerous and many theoretical positions. So what we try to do in the Sherpa project is pick an ethical position that is recognizable, but also recognized, has a pedigree that would allow us to describe the ethical concerns beyond the typical intuitive reaction. So when you ask somebody, what do you think is the ethics of AI, they'll say bias and discrimination. But then if you ask them, what's ethical about it, then there's the question, it becomes more difficult. And we picked the concept of human flourishing partly because it's a well-established ethical concept. This goes back to virtue ethics, goes back to Plato and Aristotle. But it also is something that resonated with the consortium, with us as the people doing the research, as a representation of this idea that humans have a potential, that humans want to achieve their potential, and the ability to do that is what we would call flourishing. And technology can promote that potential, but it can also stifle it. So that's why we chose the concept of human flourishing as the central ethical concept that we build our narrative around what AI does.
No, that's really interesting. And thank you very much for your time today. I just want to ask if there's anything that you want to talk about with the other projects you're working on, if there's any interesting updates to do with the Human Brain Project. Is there anything that you'd like to share that we haven't managed to talk about throughout the interview?
Maybe with regards to the Human Brain Project, which is a fairly high-profile project, so some of the people listening to this podcast might have heard of it. I think the interesting trajectory of the Human Brain Project is that it started out and still is at this point a research project, but it has come to the point where it is now preparing and developing a research infrastructure for neuroscience that's based on IT. And that goes back to what we said earlier, namely that you actually need the computing infrastructure in order to be able to do the research. And that's what the Human Brain Project is now morphing into. So it's moving away from doing neuroscience research into developing a set of tools that neuroscientists can do to do research. The other project I briefly mentioned earlier is called Environmental, that looks at the relationship between environmental data and mental health, is now one of the examples of a project that is trying to make use of this infrastructure. So I think it goes to show that this trajectory in the direction of more requirements to do or to use ICT for research is being realized. The Human Brains Project is turning into something that's called eBrains, which is the name of this pan-European infrastructure. And the idea is that this was going to be an infrastructure that will be open and usable for all researchers who want to make use of supercomputers, of neuromorphic computing, of neurorobotics, for the purposes of their neuroscience-related research. So I think that's an interesting observation and development that now confirms what you said earlier, namely the necessity of making these types of tools and technologies available in the hope that they will actually lead to better insights, which now in the end should hopefully translate into a better life and human flourishing.
So through these projects, you're hoping to develop some toolkits, some research tools, such as for the Human Brain Project, you're developing like a digital brain, so people, I don't know, understand the inner workings a little bit. These tools can be used in other research, I suppose.
Yes, what this eBrains infrastructure will do, it will make available certain types of data. So one of the flagship activities there is a set of atlases. So if you're interested in what the human brain or what a mouse brain looks like from the inside, you can actually go to it right now, and you can have a very detailed overview of the type of cells, where you find them, how they're distributed, how they're networked. You can also use it for simulation purposes. So there are a number of simulation tools there where you can now simulate anything from an individual synapse to a cortical column. But you can also use it to, for example, play around with neuromorphic computers. So these are computers that are based not on the types of digital machines that we tend to have on our desk, but these are computers that are based on principles of architecture and construction that are taken from actual brains. So there are various different types of tools that bring together and make sense of IT and neuroscience. And the idea is here to bring them all together in one infrastructure so that it's available to people who are interested in this field to make use and to develop their research.
And yes, if you'd like, we can share all these links and all these details on the interview description. Thank you very much for joining us.
Well, thanks for the interview.
The ResBIOS project is funded by the EU with the grant number 872146. To learn more about the ResBIOS project and the other pillars of RRI, please go to resbios.eu. Thank you for joining us. See you next time.